This is video lecture for section 2.2, variables and formulas. The first thing I'm going to do is direct you to the different things that I'll be discussing. The first part are problems that are similar to 2.2, part A, numbers 21 to 26, part B, numbers 1 to 3, and part C, numbers 1 through 3. And this is evaluating some sort of a statement with some variables, in this case A, B, C, and D, and we've been given those values. Let's quickly recap what a variable is. A variable is a symbol that replaces something that we don't know. Just like in real life, if I were to be driving down the street and without reading the words I see a red octagon-shaped sign, I know the symbol is stop. So here I have a symbol and we use letters because we could use other things. We could use symbols like stars and smiley faces, and sometimes I do that in a class, but it's easier because I have so many symbols on my to my disposal if I use letters. And also later when we work into formulas, sometimes these letters or variables can help us remember what it's standing for. So L can be standing for length, and W for width, and H for height, and so on and so forth. So in this first example, I have 7D minus 6. Now you'll notice there's nothing between the 7 and the D. When that occurs, we assume that it's multiplication. So I'm going to do 7 and multiply. Then I have to come up and substitute, in this case, D equals 8. So instead of writing D again, I'm going to replace it with 8 and then subtract 6. Then using your order of operations, I like to use the little saying, please excuse my dear Aunt Sally, and I know that sounds funny, but it stands for please, parentheses, do those first. Excuse stands for exponents, so you do those next. My and dear actually happen at the same time. So even though it says my dear in order, it could be backwards, but this stands for multiplication and division from left to right. Then Aunt Sally, again, just like multiplication and division, these are from left to right, but if the subtraction comes before the addition, go ahead, just reading from left to right like you do normally. Okay, so now I multiply 7 times 8. And now you're allowed to use a calculator. And over here I have my calculator set up. And I know most of you are going to be just fine with multiplying in your head and then subtracting. But just so that you know, we can bring this up on the side and jump back and forth. So 7 times 8. 7 times 8 is 56. Good. Then subtract 6. Oops. Gives me 50. Now over here I have all my answers, so I can go ahead and put it here, in some way highlight it to say it's the answer, or I made a little text box off to the side where I could put the answers. Either way. Okay, let's move to the next one. So again, we need to substitute. So I'm going to get everything down that doesn't have the variable. 3. Now nothing's in between the 3 and the parenthesis, which means multiplication. 3 parenthesis. Now this is asking for C, so we come up to the variable C and replace it with 15, add 14, and close the parenthesis. 15 plus 14 is 29 times 3. Now if you don't know that one off the top of your head, you can come over here and do 29 times 3. You can use your mouse on this, or you can type it in, or you can use your own calculator in your hand. You can also, did we do something wrong? 29 times 3. For some reason I have a different answer there. Let's come in here and I'm just going to show you one more way. Those of you who don't want to download the calculator, and it's good practice, come into Microsoft Excel. To make it calculate like a calculator, you do an equal sign, and then we do 15 plus 14 enter. There we go. Oops, I formatted that to be a dollar sign or currency. So I'm just going to come down here. There we go. Oh, that one is too. Same difference. Now I know 29. I can either put in parentheses here and actually have it calculate for me, but Microsoft Excel does something differently than the graphing calculator. In Microsoft Excel, if I want to do 3 times that, I actually have to tell it in between the 3 and the parenthesis to multiply. It looks like I just typed that in wrong. I'm going to come back and fix this. I know it says a dollar sign over here. I'm going to come back and format it to be just a number. Takes just a minute. There we go. Do general. There we go. So now it's just a number for those of you who that might be confusing. Or on this one, if you wanted to type it in as you see it, 3 parenthesis. Now in a calculator, a graphing calculator, you don't have to put the multiplication sign there. It automatically knows, like we know, that it's multiplying. It won't do anything wrong to put a multiplication sign in there. So I could do that, but it's up to you. You don't have to. And since I know that, I'm not going to. And I'm just going to do 15 plus 14, close the parenthesis, press enter. There we go, 87. So our answer was 87 with substituting in C. So I'm going to write equals 87. And we have 2 ways of doing this. I'm going to highlight that as being the answer, or over here I just put down my answer key. Okay, let's move to the next one. 24 over A plus B. So we're going to substitute 24 divided by A was given to us as 4. Adding B is 5. Okay, so 24 divided by 4 is 6. 6 plus 5. And the reason I did the division first is please excuse my dear Aunt Sally, the order of operations. I don't have parentheses or exponents, so please and excuse are gone. My and dear's multiply and divide, whatever comes first from left to right. In this case, I have a division sign, so I'll go ahead and divide. And then the last step is adding and subtracting from left to right. There we go. So I get 6 plus 5 is 11. Highlight my answer. In the last video, I talked about inserting an equation. And that's helpful because you can put in fractions that look nice, such as this down here, and exponents. In this one, you'll see I don't have an equation. I just used my superscript button at the top. And most of you will be doing this by hand anyway. But just so you know how to do this in a computer, for Math 108 you'll need that. Okay, so now I'm going to substitute 13, and then I'm going to subtract. B is 5, and so I'll do 5 to the 4th. Now something I haven't talked about yet, and what I always do in my other classes is I put parentheses around whatever I'm substituting. So if it's A, I'd put a parentheses around the 4 and put that, the parentheses in the 4, where I found the A. In this case, I find it extremely helpful to put it around the 5 because I know that the 5 is a positive 5 and not a negative 5. And if I were to do the negative to the 4th power, that's a negative times a negative, that's positive, times it by another negative, so we have 3 negatives, a positive times a negative, and then times it by another negative makes it positive, and this is a negative sign, not a positive sign. So I kind of like doing that. So I'm going to go ahead and do that from now on by putting parentheses around the numbers that I'm substituting into the variables. It just helps keep things straight. Okay, in this case, I need 5 to the 4th first because in my please excuse my dear Aunt Sally, I have an exponent. So I'm going to come over here and do 5 caret 4 and enter, gives me 625. I can also do this in Microsoft Excel if you don't want the calculator. Equals 5, then you do shift 6 for the caret to the 4th, pressing enter, 625. Oh, apparently I didn't format that cell. Okay, so now I know, and I'm going to unsuperscript, that 5 to the 4th is 625. And I haven't done anything to the 13 yet, so I'll do 13 minus 625. There we go. Now it's just a matter of adding and subtracting. That's the last step in the order of operations. Please excuse my dear Aunt Sally. So I can come up here and I can do equals. In fact, I'm going to do a cell reference just to show you one more trick with Microsoft Excel. So I'm going to say equals 13 subtract, and instead of writing 625, I'm going to cell reference by just clicking in the cell above, because that cell is 625. Press equals. Now in this one, because I'm working with money and Microsoft Excel does finances, the red means that I'm in the negative. So this is negative 612. If you didn't like that and you want to use your calculator, we can just do 13, and I'm going to type it in with my number pad off to the side now, minus 612. So I have two ways of doing this over here as well. Oops. I did that wrong. 13 minus 625. There we go. Gives you negative 612. So you have two different ways of doing that, and I'm going to come over here and say that's my answer. Oops, I highlighted everything. Just this part. There we go. Okay, let's move to the next one. A minus 12. This one's kind of nice. A is 4, so I'm going to substitute it in, and from now on I'm going to do parentheses and substitute the number for the variable 4 minus 12. A positive 4 minus 12. 4 is in the positive, so it's like having $4, and I'm subtracting 12. That's negative 8. There we go. So it's in the whole 8. Okay, the next one, 3c. Now nothing's between the 3 and the c, but we automatically assume multiplication. So we have 3, and I can put times, or I can just leave it. And I'm going to substitute in c, which is 15, and I'm going to use parentheses. It's good practice for when you get into further math as well. It kind of keeps things straight. So 15 minus 0.5. Again, I'm going to substitute in d, so parentheses. D is over here, 8. Close the parenthesis and add 2. Parenthesis, go find A. A is 4, so I'm going to type in 4 and close the parenthesis. Now this one I have several more operations. I have a multiplication sign here, a subtraction sign, multiplication, addition, and multiplication. Using our order of operations, please excuse my dear Aunt Sally. Now some of you are thinking, wait a minute, she put parentheses in. And the first step in the order of operations, please excuse my dear Aunt Sally, the P stands for parentheses. So I come inside here and I know some of you are thinking, shouldn't she do something? Well, there's nothing to do in there. It just says 15 with those parentheses. That's it. There's no operation to do, so we don't need to worry about it. Those parentheses are really just stating that I've put in this number for the letter or the variable. Okay, so now I have multiplication, subtraction, or addition. Those are the three kinds of operations. Please excuse, I don't have any parentheses that I have to work with. Excuse, I don't have any exponents. So the next thing is multiply and divide from left to right. My dear. So I'm going to come up here and do 3 times 15. I know some of you already know that's 45. So we're going to come over here. That's 45. Subtract. Now 0.5 times 8. 0.5 is the same as 1/2. Half of 8 is 4. Add 2 times 4, which is 8. Now, please excuse my dear. All of those have been taken care of and I only have adding and subtracting. I have a subtraction sign and addition sign. Some of you might try adding first and do 4 plus 8. But remember, please excuse my dear Aunt Sally goes from left to right when we do multiplication and division and adding and subtracting. So you need to from left to right, start with the 45 and subtract the 4. So 45 minus 4 is 41. Now I can add the 8, which gives me 49. There we go. If you need to write on your paper, please excuse. I would put some spaces because my and dear is the exact same. Oh, we could even put a space there. My and dear is the same step. Aunt Sally, add and subtract. That's the same step. Just remember it's from left to right. In fact, when I teach this in a classroom, I always put a little arrow sign up here, like this, showing that you add and subtract and multiply and divide from left to right, but they are the exact same step. There we go. Okay, let's move to the next one. This one, I'm going to go ahead and insert an equation just because it looks nice to have that as a fraction. So I'm going to bring in my fraction tool. Inserting my fraction, I have 10 on the top. Nothing's between the 10 and the b, so it's multiplying. And I'm going to replace b with 5. I'm going to close the parenthesis, subtract 5 for the top. Then I'm going to arrow down 2 and find a with parentheses. A is 4. And then subtract 3. I'm going to arrow over to get out of the fraction and add. C is 15. Oh, I should erase those. C is 15. Arrow over. So I'm going to do parentheses 15, close parentheses, times D, because nothing's in between the C and the D. We know it's multiplying. D is 8. Close parenthesis. Okay, now it's a matter of the order of operations again. So I'm going to look at this fraction and see what in there can I kind of simplify. I have multiplication and subtraction, so the first thing I want is multiplication because that comes first in the order of operations. And I'm going to insert another equation so I can get this fraction looking nice and organized. Arrowing over, 10 times 5 is 50, and I'm going to leave the subtract 5 on the top. I know some of you can already do that in your head right now, but I'm going to do that in the next step just so that we can see exactly what's happening. 2 times 4 happens first before we subtract over, and then I need to add, and I can go ahead and multiply as well right here. 15 times 8, which gives me 120. There we go. Now I'm going to do the next step, which is equals, and I'm going to insert yet another equation because I have this fraction still going on. Okay, and on the top, 50 minus 5 gives me 45. 8 minus 3 is 5. Arrow over to get out of the fraction, add 120. And the last step here, so now I've done within this over here, so I added and subtracted. Now some of you are thinking, well, division comes before adding and subtracting, right? And this fraction line right here is the same as a division sign. However, in this one, there is an unspoken set of parentheses saying I have everything on the top here doing something and everything on the bottom. So there are an implied set of parentheses even though they aren't there. Whenever I have a long division sign, that the top needs to be taken care of and the bottom needs to be taken care of before you can divide. So it's that, it's kind of a tricky one where there's the implied parentheses. Okay, so now I have 45 over 5, and I don't need to insert another equation because that simplifies to 9. Add it to 120, so I divided first. Adding and subtracting is the very last thing. Add those together and I get 129. And I'm going to highlight that as my answer. Okay, the next section is using a formula. Rate times time equals distance, or distance equals rate times time, same thing. This is similar to problems in 2.2 Part A, numbers 27 to 29. It's asking for the distance. It's giving us the rate and the time. So I'm going to come over here and let's substitute things in. I know I need rate times time equals distance. Rate, time equals distance. Now it's just a matter of substituting. Rate is given to us as 65 miles per hour. Actually, I'm going to show you a little bit of the units on this as well because I like this. 65, this miles per hour means I have miles on top over hours. So it's kind of a continuation from the last section about units. So that's the rate. So I've taken care of this part of the formula. Now I need time, and there's nothing in between here, so that means I'm multiplying. I can put multiplication there or I can leave it. I'm just going to put a space and times 4 hours. Now this isn't a fraction, but I could make it one by putting it over a 1. So this is in the numerator. And by the way, this is all equaling distance. Just as a fun little fact here, I have hours on the top and the bottom, which means I can cancel those out. And I no longer have hours. The reason that's convenient is the only unit left now, once those hours cancel, is miles. And distance is measured in miles. It's kind of like a second checking method for you. So now I need 65 miles times 4, and that will give me the distance. I'm just going to put that in here with the distance in between, knowing that that equals distance. 65 times 4 gives me 260 miles. So it was just a second little verifying that I am on the right track when I'm using this formula. Since we've already shown that we can cancel out the hours, I'm just going to go ahead and do the numbers on this one now. So I know I need rate times time. Rate is 20. 20 rate times time. I was given 2.5 hours. 20 times 2.5, that's 2 20s and half of a 20. 2 20s is 40. Half of a 20 is 10, so that should give me 50. If you don't want to do that one in your head, 20 times 2.5, 50. There we go. And I know that it's giving me distance, and we already showed that the unit conversion, when I multiply by hours, I'm left with only miles. So my answer is 50 miles. Let's go to the next one, money totals. This is similar to 2.2 Part A, numbers 33 to 35, Part B, numbers 7 through 9, and Part C, 7 through 9. Here they've given us quarters, pennies, nickels, dimes, but not a whole lot of information about it. What I like to do is I just look at what it's asking for and put the value of the nickels, the dimes, the quarters, the pennies, times it by how many you have. One way of thinking of this is, just as a side note, not specific to number 10, is if I have 5 pennies, 5 pennies, each penny is 1 penny, or 0.01. 5 of those means I have 0.05. So what did I do to get from 5 pennies to 0.05? I know you're adding it in your head, but we can break it down by saying 5 times 0.01 will give me the value of all 5 pennies is 0.05. So I know they go through a whole lot of information on your in your book, giving you the equations or whatever. You really don't need those because you know how much quarters, pennies, dimes, and nickels all are valued at. So here I have 3 quarters. So I need the number of quarters and times it by the value of each quarter, just like we talked about with the pennies. And I'm going to put mine in parentheses just like I did before so that I know that the 3 and the 2.5 are separate. So now this shows me I have 3 coins of the value 0.25. Now I need to add this by whatever else I have. In this case, I have pennies, and I have 19 of them. So I need how many times it by the value of a penny is 0.01, and this will give me the total I have, or in their case, they say value for the whole money. What did they call this? Money totals. Okay, so 3 times 0.25 gives me, I'm going to come down a line, 0.75. Add it to 19 times 0.01 gives me 0.19, which adding those together gives me 9 and 5 is a 4, carry the 1 is 0.9, 0.94. Yep, there we go. And let's go ahead and put a money sign or a dollar sign on that to label the units. Okay, let's move to the next one. In this case, they didn't tell me anything about the dimes. So here, they told me how many quarters and how many pennies, so I could come up with the actual money total. This one, because it's telling me dimes equals dimes and nickels equals pennies plus quarters, there's really nothing I can do with finding an actual amount because I don't have an actual amount. Oh, I've gone ahead. Let's show you how I set that up. Okay, so I have all of the different values. In this case, it's telling me dimes equals dimes. So I need my dime, the number of dimes, to be just D. So up here we did 3 for quarters. Here I don't have it, so I can't put anything. D, and then the value of dimes is 10 cents, or 0.1. If you would like to put the 0 on there to make it look like 10 cents, that's fine as well. Now I need to add it to whatever else I have. Nickels. Nickels are valued at 5 cents, or 0.05. And then the number of nickels is P plus Q. P plus Q, or pennies plus quarters. This equals the value. Now let's simplify it up just a little bit. 0.1 times D is 0.1 D. Over here, however, I'm going to use the distributive property. The distributive property says, since I can't add P and Q within the parentheses and the order of operations tells me, please excuse my dear Aunt Sally, I must do parentheses first. But I can't add P and Q because I don't know what they are. So to work our way around it, the distributive property says we can multiply both of these by what's out in front. So 0.05, oh, did they go further into that? Yep, 0.05 times P, 0.05 times Q. Oh, and it looks like I didn't put the 0 in there for the nickels. And I need to change my answer over here. 0, 0. There we go. Okay, so 0.05 times P, 0.05 times Q gives me, and I'm going to change it down here for my next step, 0.05 P and 0.05 Q. Now, is there anything here I can combine? No like terms, meaning there's not another term here with a D, not another term here with a P or a Q. So that's it. That's the answer. I can't figure out the total value because they didn't give me any more information. Let's go to the next one. Again, Q equals Q. This means that I won't be able to find the exact amount or total because I'm being left with variables. Here's another one. Q plus 6 is the dimes, and pennies is D plus 1. So let's start from the beginning. Quarters. Quarters are 0.25. 0.25 times Q. And I don't know how many Q's, so I have to leave it. Now I'm going to add dimes. Dimes are valued at 10 cents. So I can put 0.10 or 0.1. Same thing. And then I'm going to multiply it by how many dimes I have. In this case, Q plus 6. Q plus 6. And I'm going to close parenthesis. In fact, I should have put a parenthesis here as well, as we talked about. Now I'm going to add pennies. Pennies are valued at 0.01. 0.01 times how many pennies I have? I don't know. I just know it's one more than the dimes. So I'm going to put dime plus 1 and close the parenthesis. There we go. That's the value. But I do need to simplify a little bit. 0.25 times Q is 0.25 Q. Now the next one I can use the distributive property. The distributive property is when I multiply this into every single term, and terms are separated by a plus or a minus sign. So here I have the Q and the 6. So I have 0.1 times Q is 0.1 Q. Add 0.1 times 6 is 0.6. Then I have another distributive property over here. 0.01 times D is 0.01 D. 0.01 times 1 is plus 0.01. Now in this case, I have things that I can combine. I have two terms with Q. So I can add those together. 0.25 plus 0.1. You did this by lining up your decimals in the previous lessons. So I have 0.2 and 0.1 add together gives me 0.35 Q. Nothing can add to the D, so that one's all by itself. So plus 0.01 D, 0.6, and then my last ones are 0.6 and 0.01. Those actually don't have a variable with them, so I'm just going to put 0.61 by adding those together. There we go. There's my answer, and this equals, the value equals this. Oops, there we go, equals. Okay, let's move to the next one. This one, it's looking like I could actually figure out the total, except that the next one on quarters and nickels, I have a letter or another variable, so I can't actually find the whole thing out. But let's start at the top, pennies. The value of a penny is 0.01. Now I'm going to put a parenthesis because I need to know how many pennies I have. In this case, 8. 8, close parenthesis, and add it to the next money value. Quarters. Quarters are 0.25, and parenthesis with how many I have here. I have A plus 72. Close parenthesis. Add. The next value I have are nickels. Nickels are 0.05, and within here I have A minus 20. A minus 20. There we go. Okay, so the next thing we need to do, 0.01 times 8, 0.08. Multiplying those together. Remember the order of operations. We need to do all of the multiplication first before we can add and subtract. However, here, parentheses would come first because of, please excuse my dear Aunt Sally, but I can't add A and 72, so I'm going to multiply with the distributive property, 0.25 times A plus 0.25A, and 0.25 times 72, 0.25 times 72 in your calculator gives you 18. So plus 18. Now if you didn't want to use a calculator, remember you can always go into Microsoft Excel and do equals and treat it just like a calculator. 0.25 times 72. There we go. We still get 18. One benefit with Microsoft Excel, if you are doing a money value, you can copy and paste into your Word document and it's already rounded and it has the dollar sign, so it's kind of nice that direction too. Okay, so now let's move to the next part. Another distributive property here, 0.05 times a, 0.05 a, and 0.05 times negative 20. Come over here, equals 0.05 times negative 20. Gives me negative 1 or minus 1. Okay, now we need to look through and see if there's anything I can simplify here. I have 0.08 and negative 1, so I could combine those. Oh, and I have 18. Those are all just numbers that I can combine together. I don't think I did that on here, on my next one. Oh yes, 0.08 and a negative 1 give me negative 2. I've done that wrong on my answer key, so let's fix it. 0.08, oops, want it to calculate, so make it equal 0.08 minus 1 plus 18 gives me 17.8. I must have been doing that in a hurry. 17.8, because that's a negative and not a positive. 17.8. It's nice to see when the teacher makes some mistakes, because then you know nobody's perfect and it's okay. Laugh about it. It's just math. Okay, so let's move on. So now I've combined this one, and this one, and I'm left with negative 17.8. And over here, let's see, I have 0.25a. Oh, and here's another term with a, 0.05. So 25 cents and 5 cents added together gives me 30 cents, oops, 0.3. And I could put the 0, but it's after the decimal, so I can leave it. It's up to you. And then put an a. There we go. There's the answer. And it seems to match now that we fixed it. Let's move to the next one, temperature conversions. So the formula was given to you on your formula sheet or in the chapter, but you will also notice it's in your formula sheet. And quickly I'm going to go in and remind you where you can find that. This is for test number 2. And I would actually print this off in advance and just keep it close at hand so that as you're working through your homework, it has all the formulas for you and you're already familiar with the paper so that by the time the test comes around, it's not, I guess, a little bit more jarring or scary to see it because you're familiar with it. Go to Course, Resources, Exam 2 Formula Sheet. I would click on it to show you, but I think it will download it again, and I don't want to download it because I already have it over here. And it's a really nice reference. Print it off and keep it at hand, especially if you're a tactile learner. Tactile learners and kinesthetic learners and visual learners, you're going to need to have it kind of close at hand and have it in your hand. Okay, let's move back. So I have my formula. I've already typed it in. Celsius equals 5/9 times the Fahrenheit temperature minus 32. The first temperature is 250 degrees. And just so that you know, in your computer, you can go up to symbols. You might have to go find it by pressing more symbols, but there is a degree feature, and you can put that in there. Okay, so let's substitute what we know. C equals 5/9 parenthesis. I know the Fahrenheit degree, so here I can substitute in 250, subtract 32, and close the parenthesis. Now using the order of operations. Please excuse my dear Aunt Sally. In this case, and for the first time, we can actually calculate what's inside the parentheses. 250, whoops, 250, had to turn that back on, minus 32 gives me 218. Okay, so now I have 5/9 times 218, and I'm going to put that in parentheses just because if I don't, it's going to look like I have 5 divided by 9,218. I could put a time sign there, but I'm kind of a stickler for parentheses. It works it into algebra really nicely. So in this case, 218 times 5/9. So I'm going to come over here, since it's already in my screen, I'm going to do times and it'll do the answer, times 5/9. There we go. So the Celsius temperature is 121.1, and I'm only going to round it to 1. That sounds pretty decent. Oh, and I can insert my degree and highlight my answer. There we go. Let's move to the next one. Negative 33 degrees Fahrenheit. I already have my formula that we found on the formula sheet. So I know it's 5/9 times, and I'm going to put the parenthesis in there. The Fahrenheit temperature, which was given to me, is negative 33. And then I need to subtract 32 from the formula and close the parenthesis. Okay, so please excuse my dear Aunt Sally means parentheses first. So inside here, I need to subtract. Negative 33 minus 32 gives me, and I'm going to put that in parentheses as well, negative 65. There we go. And I still have my 5/9 out front. And I need to multiply that by my negative 65. So I'm going to come up here, 5/9 times negative, oops, not a minus sign. I want a negative sign down here, negative 65. Okay, press enter, and we get negative 36.1. Insert my degree sign, or I could type out degrees with letters and type out degree. There we go. Negative 36.1 degree. Let's move to the next one. This is talking about interest, which you will deal with a lot in Math 108. So this is the simple interest formula given to us in our sheet, closer to the bottom. A standing for amount final, and I like to say it like that because then I know that the A is there, but it's the final amount, but I like to say amount final because it's the A. The P stands for the principal, times it by 1 plus R standing for rate, and they raise it to the Y standing for years because this is a simple interest. If we were doing something further, I would probably do T for time, but in our case, we're only going to be working with years, so I'm okay with that. Okay, so I'm going to hurry and put in my formula. A equals P times parenthesis 1 plus R, and then I can do a caret to say raised to the Y, or I can come up here and do a superscript and raise it to the Y. Either way works. And I'm going to put that on this page just so that we can see everything all at once. You don't have to do that on yours if you don't want to, although it is good practice. Okay, so now I need the amount final equaling the principal, which is $600, times parenthesis 1 plus, in this case, rate is 7.1%, but I don't put a percent inside calculating something, so I need to change that to a decimal. To change that to a decimal, I take the decimal and I move it over 2 places, which is 0.071. I've moved it over 2 places to the left and close the parenthesis. Then I need to raise it, so I'm going to use my superscript, 5 years. I'm going to unsuperscript to get it out of the exponent. Okay, Order of operations, please excuse my dear Aunt Sally, parentheses first. And in this case, I can actually add those together, which gives us 1.071. So I'm going to put that in here, 1.071. And it is still being raised 5 years, and I haven't done anything with the 600 yet. Okay, now please excuse my dear Aunt Sally, we did the parentheses, next is exponents. In this case, I have that, so I'm going to do 1.071. To raise on a calculator, I can use my caret button here, raise it to the 5. There we go. Now, if you aren't using a calculator and you'd rather use Microsoft Excel, again, to make it calculate, you do an equal sign, 1.071, and your caret button is above the 6, shift 6, raise it to the 5, and we get 1.49. And same thing here, 1.4009. Now I need to multiply that by 600. So my next step, I'm just going to put an equal sign here because I'm kind of running out of room. So I still have that 600, and I need to times that by 1.409, and it goes out for a while. And I wasn't told how far to go out on this one, so I'm going to keep it in my computer or my calculator or my computer screen without rounding it. Don't round until the very end. In this case, if I were using Excel, I would do a cell reference. So equals 600 times and reference what I got for my parentheses and my exponent. Enters, there we go. It tells me, and I can interpret that as being money, so I round it out to 2 decimal places, 845.47, round it to the nearest penny. Or if we wanted to do it on the calculator, we would just press times and then multiply that by the principal, which was $600, and it gave me the exact same thing. So that was just kind of a nice way to double check myself anyway. There we go. 600 and or $845. It looks like my numbers got off a little bit. I'm going to scoot this down so that they line up better. There we go. Okay, the next one we're working with euros. If you're working on your computer, you can find the euro symbol in the symbols. I've used mine recently, so it's going to show up in my more recent symbols. You can go to more symbols and find it yourself, or you can just write it out by hand. Okay, so we have 850 euros. We're going to use the same equation, and because I already typed in my formula, I have it ready to go. So I need A equals, principal in this case is 850 times parentheses 1 plus the rate. Our rate is 2%, so I need to change that to a decimal by moving it over 2 times. The decimal isn't here, so I know it is after the 2. So I need to move it over 2 times to the left. 1, 2, so it's going to be 0.02. Close your parenthesis and raise it to the years, 3.4. All right, so we can break this down again using the order of operations. In our case, we can go ahead and add that together, which is 1.02, and raise it to 3.4 years. And don't forget we have 850 euros. Okay, so I'm going to do the decimal 1.02. Please excuse, so now I need to do the exponent, raise it to 3.4. And so my next step, is going to be 850 times 1.0696, and it goes on for a while. So I'm not going to type it all out, but I do know in my calculator or even Excel, if I don't touch anything and just multiply it, it's not going to round it. It'll take that exact number, which I want, times 850 gives me equals 909.20. Oops. 909.20, and that's in euros. In Excel, we can do it the same way. Getting a little crowded in here. So we did equals. In fact, I'm going to go ahead and just type it all in exactly as we see it, because I know Excel will do the order of operations as well as your graphing calculator. 850 times, because in Excel it doesn't know what to do between the number and the parentheses. You have to tell it times 1 plus 0.02, close the parenthesis, raise it by doing Shift 6 to 3.4. There we go. Your calculator will also do the same thing. 850. In this case, I don't have to press times. I can just do the parenthesis because the calculator knows this. Close the parenthesis and then raise it 3.4. There we go. So we have lots of different ways that we can do this. We can do each step by hand, or now I've taught you that the order of operations is done in your calculator and Excel. So that's a good way to double check. Okay, the next one is pounds. Again, you can find this symbol up in Insert Symbol. You might have to search for it the first time. Using the same equation, amount final equals the principal, 68,500, parenthesis, times 1 plus 4% change to a decimal is 0.04, close the parenthesis, and raise this to the number of years. And you'll notice I just did the caret sign. It's the same difference. Okay. Now it's just a matter of, I'm going to go ahead and just plug this into the calculator since I showed you. 68,500 times parenthesis 1 plus 0.04, close parenthesis, and raise this to the 10. There we go. Equals pounds. Insert symbol, mine's right here, pounds of 101,396. And because this is money, I'm rounding out 2 decimal places to the nearest, not cent. I don't know what it is in pounds. There we go. And highlight it. Okay. Oh, somehow mine's a little different in this one. Let's just double check in Microsoft Excel just to see if I typed everything in right. Equals 68,500 times parenthesis 1 plus 0.04, close the parenthesis, Shift 6 to raise it to 10. Oh, yep, it looks like I typed that in wrong previously. That should be a 3. Okay, now let's move on to some more formulas. This is working with cones and then cylinders, and these formulas are also found on your sheet, which again I suggest you print out and just keep on hand. Okay, I've already typed in the formulas here just so that I don't have to flip back and forth. Okay, so I want to find the volume of a cone. Here's my formula, 1/3 pi r squared h. In this case, I inserted an equation and I did a fraction to show 1/3, and there's different ways of doing a fraction. You can do the sideways kind. I like having them up on top of one another because I think it kind of keeps things everything separate. 1/3. Now pi I can find over here. There's pi. If you are not doing an insert an equation, you can find pi in inserting a symbol as well. I've used mine recently, so it's showing up here. You might have to go find it. In the more symbols, pi r squared. So I'm going to do a script. In my case, r is here, 3. So I need 3, using my arrow button over, squared. Then I need to come out of the superscript by moving my arrow button over and times this by 4. Okay, so now we need to type all of that into my calculator or into Excel, and I'll show you how to do both. In your calculator, 1/3 times pi. Pi is over here. See this little blue thing? To get that blue one, we have to do second in the caret button to get pi. And then we times it by 3 squared, 3. I could do the caret button and do to the second power, but it already has a built-in squared. So I'm going to go ahead and use that one. 3 squared times 4. There we go. 37.7, and we'll talk about the units in a moment. To do pi in Excel, we do equals 1/3. Microsoft Excel, you have to tell it times in between each number, times pi, P-I, and close your parentheses. So Shift 9, Shift 0. So that's 1/3 times pi times 3 squared, 3, Shift, and then do your caret, squared, and then times 4. There we go. Same answer either way. Equals 37, and I'm just going to round it to 0.7. Now let's talk a little bit about units. I'm going to come down here to the formula. 1/3 didn't have units. Neither does pi. Pi is just a ratio of the circumference of a circle to its diameter. So pi is unitless. It's just the ratio, 3.14159, and so forth. R is the radius. The radius is a measurement, in this case inches. So I have inches being multiplied. The height is also, for this cone, is also being measured in inches. So I have inches times inches. In that case, I have inches times inches, which is inches squared. And that's where we get the units here as being inches squared, because I had two dimensions in here, the radius and the height, being multiplied together. Okay, let's try the next one. For the surface area. The surface area is pi r L, radius, and the length, and then pi r squared. So I'm going to come up here and type in pi, insert, pi, and then I'm going to do a parenthesis for r. R is 13, substituting it in. And then I'm going to do another parenthesis for the L, which is 10, close it, plus pi again. Oh, there it is. And then r squared, so parentheses, r is 13, and then raise it to the 2. Okay, now again, using the order of operations, we need to multiply or do the parentheses first, but nothing's within here that we need to calculate. So the next would be exponents, so 13 squared, and then we would come back and do all of these multiplication. Or we can type it into Excel or into your calculator. So I'm going to do pi, close your parentheses, open and close your parentheses. In Excel, you have to press times 13 times 10 plus pi again, open and close your parentheses, times 13, shift 6 for your caret, squared. Now some of you are thinking, wait a minute, how can I just type that all in? Microsoft Excel and the calculator already know the order of operations, and they will do them in order and give you 939.3. Or we can do it in our calculator. So I would do second, pi is here on the caret, 13 times 10, and I have to do the time sign there because it would look like the calculator would think it's 1,310. So I do have to put it there. Plus pi again, second pi, and then 13 squared. I could do a caret 2, or I can just press a squared button. In between here, pi is separate from the 13, so I don't have to put the time sign. There we go. Same answer we got on both. 939.3. Now let's talk about the units. I had being multiplied the radius and the length. Over here I had radius times radius. So here I had yards times yards, which is yards squared. Here I had yards times yards, so I have yards squared. That's good, because if they are the same units, then I can add them together. So both of them were yards squared, so I added them together, and I'm still with yards squared. There we go. Oops. And we can highlight that to show it's the answer, and move to the next one. This is the lateral surface area. So I have pi RL. That one's kind of a nice formula. We don't have a whole lot to do. So I'm going to insert, or if you're doing this by hand, just write down pi R. I'm going to do parentheses, 1.4, close parentheses. I'm also substituting an L for the formula, 3.1, so put parentheses there. And that one's just multiplying. I'm going to use my calculator on this one. Pi times 1.4 times 3.1, oops, over arrow 3.1. There we go. 13.6. And in this one I had the radius, which was being measured in centimeters, and the length being measured in centimeters. So I need centimeters times centimeters, which is centimeters squared. And that's how we got our units. Okay, cylinders. This is very similar to the cones. This is similar to 2.2, Part C, numbers 13 through 15. You know, yeah, okay. Okay, so I've already gotten our formulas from our formula sheet that we talked about earlier. Pi r squared h. So I need pi r squared, so I'm going to do parenthesis. R is 5, close parenthesis. Raise it to the 2. 5r squared times h is 2.3. If I were doing this by hand, I would do the 5 squared first, using the order of operations. Please excuse my dear Aunt Sally. There's no set of parentheses I have to work with inside, so the next would be exponents. 5 squared is 25, so it'd be 25 times pi times 2.3. So I can do pi times 25 times 2.3. There we go. 180.6. And that sounds about right. Now the units, I have radius squared. That means I have radius times radius, or millimeters times millimeters. So that's millimeters squared. But then I have the height, which is another millimeter. That's 3 of those millimeters, which means this is millimeters cubed, because I had 3 of those being multiplied together. There we go. Okay, let's talk about the surface area. The formula for this is 2 pi r h plus 2 pi r squared. I'm going to actually copy and paste this up here. This is kind of fun, and so it'll speed us up just a little bit. And I'm going to replace r with what I was given as r, put a parenthesis, and type in 10, and then replace h with 6. And again over here with r, put parentheses around the 10 and put it in. That's kind of nice to see that it's actually being substituted in, and I'm replacing it and taking out the variables and substituting in the numbers that I know. Okay, so 2 pi times 10 times 6 is 60, and 2 pi 10 squared is 100. So I could do part of that in my head, or I could do it all in working it out, or I can use my calculator. So this one would be 60 times 2, which gives me 120. So that's 120 pi plus 100 times 2 is 200 pi. Or I can just plug it into my calculator or type it into Excel, Microsoft Excel. It's up to you. Because I did do a lot of that in my head just now, I could type it in. However, sometimes I make mistakes, and so I'm going to just be really cautious here. I don't need the time sign there because I'm not in Excel. 2 pi. I'm pretty confident on the 10 times 6, so I'm going to go ahead and put 60 on there. Then plus 2 pi. 10 squared is 100, so I'm going to go ahead and put 100. There we go. And I'm going to do equals 1005.3. Okay, let's talk about units again. Radius is measured in meters. The height is measured in meters. So I had meters times meters. That's meters squared. Let's check this side that I'm adding to. Radius times radius was meters times meters. That's meters squared. That means that I could add those together because they're like terms. So that's good. That's another way to check it. And that's meters squared. There we go. Okay, the next example. This one's looking for the lateral surface area. So if it were a can, because this is a cylinder, I would be looking at the label of the can, that part that's covered by the label. So I'm going to copy and paste this up. There we go. And I'm just going to come in here and replace those. The radius, I'm going to put parentheses, is 8. The height is 5.1. And we can just plug that into the calculator of 2 pi 8 times 5.1 gives me 256 point, and then I'm going to round up and just go at 1 decimal place just because. Now let's look at the units. I have radius times height. The radius was feet, height was feet, so I have feet times feet, which is feet squared. There we go. This is turning out to be a longer lecture than planned, so I'm going to go ahead and stop halfway through and do a part 2 for the second part, in which we'll cover triangles, trapezoids, rectangular solids, and simplifying some equations already written. So if you want to finish this lecture, go ahead and join me in the second section.